All right, in this video, we are going to work through this exercise here, this example. It says use identities to fully simplify the expression. So the expression that we have is sine of the opposite of x times cosine of the opposite of x times the cosecant of opposite of x. All right, and so we want to use the identities to simplify those. Here is the list of identities. So far in this course, we've covered from Pythagorean identities down to the even and odd identities. All right, so it helps to take a look at those identities to kind of see which ones you might be able to use to simplify things. And then obviously, right, looking at this problem, we have a lot of the opposite of x inside of the parentheses inside of the trig functions, okay? So looking at these even odd identities, these identities can be used to simplify that down. On each of these, you can see on the left-hand side of each of these identities, I have the opposite of x, and then on the right-hand side of each of the identities, the argument, the thing inside the trig function is just x there. So basically, we can do that. We can, and that's what the purpose of the even odd identities is to reduce those negatives down inside of the trigonometric functions. All right, so looking at the first one, sine of the opposite of x, that's equal to the opposite of sine x, right? So that's the first one that I'm going to use here. So I'm going to write that as the opposite of the sine of x. All right, next up, I have cosine of the opposite of x. So I'm going to look at those even odd identities for cosine. Here you can see that the cosine of the opposite of x is just equal to cosine. So I can rewrite that as just cosine. For the cosecant of the opposite of x, looking at the even odd identity related to it, it is that the cosecant of the opposite of x is the opposite of cosecant x. All right, so I'm going to write that with parentheses so it doesn't look like subtraction. Right, if I don't put those parentheses around there, then it could look, or multiplication sign, it could look like I am multiplying, subtracting instead of multiplying there. Okay. All right. So next up, right, I can see that I have basically the opposite sign here, the negative sign here. Right, that's kind of like a -1 and a -1 with those factors, and so multiplying those two together, right, would give me just a +1, right? So those two negative signs basically cancel each other out, is a way to think of it. And so I can rewrite this more simply as sine x times cosine x times the cosecant of x, okay? Okay, and so next up, again, I can try to simplify this a little bit further. Sine by itself that's about as simple as it gets, and cosine, I'm not really going to be able to simplify that anymore. But cosecant of x, right, if you look at the reciprocal identity for cosecant of x, that's 1 over the sine x. And so I can use that to make this simpler. So I'd have sine x times cosine x times 1 over sine x, like so. And I can think about these as being fractions as well. And so I'm multiplying these three fractions together. Everything is multiplication, right? And so I can see I have some factors on the top that are common to factors on the bottom, and that is sine x, right? Sine x is a factor of the top and of the bottom. So it's a common factor, and I can cancel that out. So sine x here, that is a 1. I cancel that with a factor of sine x in the denominator. That becomes a 1. Okay, and now to multiply these fractions, I just multiply the numerators. So 1 times cosine x times 1 is just cosine x. On the bottom, I have 1 times 1 times 1. That's 1. So it's cosine x over 1, which is just cosine x. So this entire expression, right, boils down to cosine x when it's defined. Okay, so it will be the same for all values, right, as long as we're using a value where cosecant x is defined. Okay. All right, and that is it on this example.